This video is on the course of representation theory, and we are still on the chapter of group representation. I'm doing a couple of videos doing further revision on linear algebra. So in this video we introduce the concept of unitary matrix. Okay, so a unitary matrix is a matrix that is equal to its conjugate transpose. Okay, and we use this star symbol for unitary. So you can write it this way, and of course a unitary matrix U times U will be equal to the identity. Please check the previous video for this. Okay, so the real analog for these unitary matrices is the orthogonal matrix. Please check the previous video for this concept. So some characteristics of these unitary matrices: if you have complex vectors, imagine you have vectors x and y. Okay, if you multiply these vectors by u, if you multiply by u, and if u is a unitary matrix, u will preserve the linear transformation U preserves the inner product. So let me write this in the, so we have U times X, U times Y, the inner product of those two, where X and Y are complex vectors, right? So Ux inner product Uy will be equal to Xy. Okay, the inner product is preserved. Okay, some other characteristics. U is a normal matrix. Please check the previous video for this sort of concept. U is diagonalizable. Very easy to check that U is diagonalizable, and the determinant of U will always be 1. Okay, so of course this is a matrix that it's like the previous one, the special orthogonal ones. A very important fact about U is that its eigenspaces are orthogonal. And last, if we pick n in the integers, this set of n by n matrices with matrix multiplication, they form a group. So you pick these matrices, dimension n by n, and multiplication, and they form a group. The group is called UN, a very well-known group called the Unitary Group. Very important group in quantum physics, in geometry, in lots of applications. Okay, so this will be the unitary group, a group. So it will be matrices, unitary matrices, and a multiplication. Okay, they form this unitary group. Last, I'm not going to spend a lot of time on this. This is a huge fact. You could write a book on any of these facts. Okay, but any square matrix with unit Euclidean norm is the average of two unitary matrices, but we are not going to get on this, okay? So unitary matrices, they live in this group, the unitary group, under multiplication. And they have this form, or the better first look at it is this one.